Astronomers zoom into cosmic dust and find supermassive black hole hiding within. Astronomers have found new evidence for a unified model of active galactic nuclei. They revealed a ring and disk dust structure that obscures the supermassive black hole in the active core of the M77 galaxy. What is the unified model of active galactic nuclei? A unified model of active galactic nuclei was developed at the end of the last century. It says that all active galactic nuclei have a similar structure and contain a supermassive black hole, surrounded by a rotating accretion disk and generating jets of matter, that are directed perpendicular to the disk. The whole system is surrounded by a thick dust torus, and the observed differences in the properties of the nuclei are explained by differences in the viewing angle. The torus is able to partially obscure the black hole from the observer or completely hide it. Illustration of the active galactic nuclei model. Astronomers distinguish several types of AGNs, quasars, blazars, as well as active nuclei in Seyfert galaxies and radio galaxies. Some of them emit powerful bursts of radio waves, others are characterized by a continuous spectrum, in all ranges of electromagnetic radiation, and some AGNs, such as Messier 77, do not differ at all from ordinary spiral galaxies in the optical range. Astronomers have previously found some evidence to support a unified model, including after the discovery of hot dust forming an annular radiating region at the center of Messier 77. However, there were doubts whether this dust could completely hide the black hole, and therefore explain why this AGN shines less bright in the visible range than others. The new work partly dispels doubts. An image of the spiral galaxy Messier 77 taken by the Hubble Space Telescope. Astronomers found a black hole in a ring of cosmic dust. A team of astronomers led by Violetta Gomes-Rosas of the University of Leiden in the Netherlands, has published the results of an analysis of observations of the M77 spiral galaxy, which has an active nucleus and is located 47 million light-years from the Sun. The observations were carried out in the infrared range using the MATISSE, multi-aperture mid-infrared spectroscopic experiment, spectrograph mounted on the VLTI interferometer. Scientists wanted to understand the structure of the galactic core, based on mapping the temperature distribution of dust near a black hole. Observational data from the ALMA radio telescope were also used in the work. Center of the M77 galaxy. The dot marks the most probable position of the black hole, the ellipses show the outlines of the dust ring, dashed line, and the dust disk. The researchers identified a dust structure consisting of an optically thick ring covering the central machine, a black hole with an accretion disk, on a parsec scale, and a less optically thick disk extending at least 10 parsecs. This structure obscures the black hole from an Earth-based observer looking at the disk almost edge-on, as predicted by the unified active nuclei model. In addition, scientists have registered the emission of polar streams from the black hole, as well as dust blowing. At the same time, the dust in its properties differs from the typical interstellar dust of the Milky Way. It is possible that the dust grains in the center of M77 are submicron olivine particles rich in magnesium and with little carbon. Future VLTI observations of other active galactic nuclei are expected to provide further evidence for a unified model.